So we were dealing with alternators. The other name for alternators was synchronous generators. What is a synchronous generator? Can I look at the diagram? This is from Westinghouse, a famous manufacturer of alternator. See how big the alternator is. This is an alternator present in hydro power plant. There is a generator and there is an exciter. Synchronous generators are, in general, the synchronous machines are of two types: synchronous generators and synchronous motors. What is a generator? Generator converts mechanical energy to electrical energy. That is what we discussed. And we also emphasize the importance of generators. It is the primary source of electrical energy we consume today. Without alternators, there will be no power generated and the entire world will be in dark. So that is the importance of these generators. Synchronous motors does the opposite, converts the electrical energy into mechanical energy, and it is used for constant speed applications. So we will come to the synchronous motors later. I'm just reviewing previous class topics for 5 minutes, and then we will move on to the today's class. So synchronous machines are divided into two types: synchronous motors and synchronous generators. We are dealing with synchronous generators or alternators. So construction, any machine will have a rotor and a stator. In the case of a synchronous generator and alternator, your stator has a three-phase distributed winding. We have already seen there are three-phase windings distributed from each other by 120 degrees. And your rotor is provided with a DC excitation. This is what you have seen in the last class. Remember, the rotor is provided with a DC supply. The stator has a three-phase distributed winding from which the power will be tapped out. The armature windings are distributed with respect to each other, are distributed in space with respect to each other by 120 degrees. And because of this distribution, we have a three-phase supply. Look at this waveform. The R phase is in red color, Y phase is in yellow color, and B phase is in blue color. So we have a three-phase supply. So you have a stator and you have a rotor, and the stator has three-phase windings. Look at this A, B, and C, and these three windings A, B, and C are distributed in space with respect to each other by 120 degrees. Three stator windings 120 degrees apart. And look at the rotor. Rotor is provided with the DC excitation, and that DC excitation is called as the excitation voltage. DC excitation is called as the excitation voltage. And the current due to this voltage, excitation voltage, since the windings are short circuited, is IF. Is it clear? Rotor is provided with the DC excitation. Stator has three-phase distributed windings distributed in space with respect to each other by 120 degrees. Because of which we are getting this three-phase waveforms. Again, three-phase voltages distributed by 120 degrees with respect to each other. It's three-phase supply. As I already told you, the field winding will be energized with the DC supply, and the current IR, the field winding current, can be given as IR equal to VF by RF, where VF is the excitation voltage and RF is the resistance of the field winding. If you want to find out the field current, IF equal to VF by RF, simple Ohm's law. And the rotor we have already seen. There are two types of rotor. One is the cylindrical rotor, the other one is the saline pole rotor. Can anyone tell me what is a cylindrical rotor? Use your chat or unmute and answer. What is a cylindrical rotor? How is the construction of a cylindrical rotor? Am I audible? Chandru?
Yes, sir.
What is a cylindrical rotor? We have seen two types of rotor, right? In the last class. Cylindrical rotor and salient pole rotor. So what is a cylindrical rotor? How is its construction? No answers. Yes, Vijay has posted in chat. Cylindrical rotors are used in high-speed electrical machines. Yes, it is used for high-speed electrical machines. But how is the construction? The rotor construction is similar to the stator in case of cylindrical rotor. How is the stator construction? It is three-phase distributed windings placed in the slots cut out at the periphery of the armature. So stator construction is similar to the rotor. So look at this, stator and rotor both are similar in shape. So that is cylindrical machines or non-salient pole machines. They are also called as non-salient pole machines. Coming to the diagram B, coming to this diagram B, look at the rotor construction. How is this rotor construction? What type of poles are used here? Projected poles are used. Look at the construction of the stator. It is slots cut out at the edges and three-phase distributed windings distributed in space by 120 degrees. That is the construction of the stator. But look at the rotor. You have projected poles here. You have projected poles here. So based on the construction of the rotor, we have classified the alternators into two types. One is a cylindrical rotor. The cylinder like a cylindrical in shape. That is why it's called a cylindrical rotor. And the next one is a salient pole rotor or projected poles. Look at this, the poles are projected. So this is projected poles. So can you identify the salient pole and cylindrical rotors? This is what is this type? This is a round type rotor. A round type rotor or cylindrical rotors. Salient pole rotors are projected type rotors. So you see in detail. One characteristics of the salient pole rotor is the diameter is large and the axial length is small. So when the poles are projected, the diameter will be large. Look at D. D is approximately equal to 10 meters. And the axial length, this distance, axial length is small. So that is the characteristics of the salient pole rotor. And these are low speed alternators. You already seen these are low speed alternators. They run between 50 to 300 revolutions per minute. 50 to 300 revolutions per minute. And you know the speed equation. N equal to, what is the speed equation N? Anyone? We've already seen in the last class what is N? What is the equation for N? N equal to 120 F by P. N equal to 120 into F by P. So N is directly proportional to frequency F and inversely proportional to the number of poles P. So as the number of poles P increases, N and P are inversely proportional. As the number of poles P increases, N decreases. So there are a large number of poles that are required on the rotor. So you should remember the salient pole rotors have larger diameter. They have slower speeds. Because of the slower speeds, the number of poles are required is large. These are 3 points you should note. And the most important point is they have non-uniform air gap. they have non-uniform air gap. So assume the circle is your stator and this plus-like symbol is your rotor, projected poles, North Pole, South Pole, and South Pole. So when it comes to the pole tip here, this is the pole shoe. What is the distance between that circle and this pole shoe? It is very less. But when you come here, the distance between the poles and the circle is very large. So you have a non-uniform air gap. You have a non-uniform air gap between the stator and the rotor. That is also one inherent characteristics of the salient pole rotor. Hope all of you are taking notes. By the end of the class, you submit your class notes in Google Classroom. So this is about salient pole rotor. We have already discussed in last class. So look at this diagram. The rotor will be given a DC supply. These are the windings of the rotor. There are 4 poles: North Pole, South Pole, North Pole, South Pole. The windings are supplied with the DC supply. The rotor will be given DC excitation. So that is what is shown here. The salient pole rotor is used in low and medium speed alternators. Large number of projected poles is all we discussed. Large diameters, small axial length. These are salient pole rotors. Coming to the, this is a diagram for salient pole rotor. Projected poles. So this is how, see, look at the projected poles here. 3 windings here. And coming to the cylindrical rotors, just the opposite of the salient pole rotors. Look at the diameter. Diameter in the salient pole rotor was 10 meter. Here the diameter is 1 meter, which means it has small diameter and large axial length. Look at the axial length. Length is 10 meters. Small diameter and large axial length. Just the opposite. Salient pole alternators were low speed alternators. Cylindrical alternators are high speed alternators. So for 2-pole machine, what is the speed? For 2-pole machine, what is the speed? N equal to 120 into F by P. So N equal to 120 into F by P, that is the speed equation. Assuming the frequency to be 50 Hertz. So what is N? N equal to 120 into 50 divided by the number of poles 2. 120 into 50, 50 is how much? Can you tell me what is the speed for a 2-pole alternator? Anyone? For a 4-pole alternator, what is the speed? Whether this 3600 is correct for a 2-pole alternator? See, I need some response from you people. Otherwise, I feel like talking alone. Are you there? Can anyone tell me what is the speed for a 2-pole alternator? Whether it is 3600? Karthik? Karthik A?
Sir,
Now speed enapa? The number of poles is 2. So what is the speed? 3600 இல்ல வேற ஏதாவது ஆன்சர் கிடைக்குது உங்களுக்கு? Speed equation என்னது? What is the speed equation? N equal to
120.
120 into 120 into F divided by P. So you use your calculator in the phone, or if you have a calculator, use it and tell me the answer. 120 into F by P. 120 into 50 by 2. What is the answer? Others, use your chat and post the answers. What is the speed for a 2-pole alternator? It is 3000 RPM, not 3600 RPM. Harihara Sudan has answered. And what about 4 pole? Use your chat and answer. Karthik correct. 3000. 4 pole எவ்வளோன்னு பாருங்க. பார்த்து சொல்லுங்க.
1500.
1500. Very good. So remember the speed equation 120 F by P. So we'll proceed. So diameter is small, axial length is large. It is high speed alternators. If it is high speed alternators, how will be the number of poles? ஜாஸ்தியா இருக்குமா கம்மியா இருக்குமா? N equal to 120 F by P. If N is large, how will be P? Whether it is small or large? Lokesh? Lokesh, Muthukumar, anyone? Neelakandan?
Yes, sir.
முத்துக்குமார், இப்ப ஸ்பீடு வந்து ஜாஸ்தியா இருக்கு, நம்பர் ஆஃப் போல்ஸ் எப்படி இருக்கும்? கம்மியா இருக்குமா ஜாஸ்தியா இருக்குமா?
கம்மியா இருக்கு.
ஸ்பீடு வெரி குட், கம்மியா இருக்கும். ஸ்பீடு ஜாஸ்தியா இருந்தா நம்பர் ஆஃப் போல்ஸ் கம்மியா இருக்கும், because both are inversely proportional. Very good. So our saline pole alternators have large number of poles, but the cylindrical rotor alternators have smaller poles. And look at this, there are only 2 poles here, north pole and south pole. And these are ratings up to 2000 MVA. The saline pole alternators are low rating alternators, whereas your cylindrical rotor alternators are high rating alternators. And what about the air gap here? Look at the air gap. Air gap is uniform. Air gap is uniform. This is the stator and this is the rotor. Both rotor and stator construction are similar. So air gap is uniform here. These are some construction difference one should know before proceeding with the class. This we have seen in detail. Hope you remember the tabular column. We distinguish between the cylindrical rotor and saline pole rotor in the last class. So let me proceed. So these are some points. Cylindrical type rotors are used in high speed alternators. These are also called as turbo alternators. So this point also we discussed last class. Turbo alternators. Field windings are placed in the slots. See, field windings are given a DC supply and the field windings are placed in the slots. So this is one slot, this is one more slot, this is one more slot. In the slots there are conductors. Conductors nothing but windings. So these windings are given DC supply. These windings are given DC supply. Always remember the rotor is excited with DC supply and we are tapping out 3-phase AC supply from the stator. So this is cylindrical rotor. This is how a cylindrical rotor will look like. Look at the axial length. Diameter was small. Look at the length of the cylindrical rotor. It is very large. And coming to the working principle of alternator and frequency of induced EMF. So what is the working principle of alternator? How does an alternator work? This also we have discussed in detail with the help of 4 positions. At the first position, the EMF induced was 0. At the second position, at 90 degrees, the EMF induced was maximum. At the third position, again 0. At the fourth position, it was maximum. At the fifth position, it is again 0. Do you remember this diagram? See, there are 2 poles, north pole and south pole, from which you have the magnetic field and you have a conductor placed in the magnetic field. And we are rotating this conductor with the help of a prime mover. With the help of a prime mover. So whenever this conductor rotates, it will change its position. And it is rotating along this axis. It is rotating along this axis in the anti-clockwise direction. Look at this arrow, anti-clockwise direction. So at this position, A, B, C, D, the flux lines will be at position number 1. The flux lines will be parallel to the conductors. So EMF induced was 0. So at 90 degrees, the flux lines will be perpendicular to the conductor. So EMF will be induced will be maximum. So rate of change of flux will induce an EMF. So we are rotating this rotor, which is DC excited. We are rotating this rotor, which is DC excited, in the presence of a magnetic field. So whenever there is a rate of change of flux, this EMF will be induced. Working principle. Again, no need to explain this further. Armature is the stator, field is the rotor. So what is the primary difference here? Which is rotating part, armature or field? Anyone? Which is rotating part, armature or the field? Yeah, very good. Field is rotating. Hari, armature will not rotate. Armature is stationary. That is the difference of the alternators from other machines. The field will be rotating, armature will be stationary. So what are the advantages of the stationary armature? I have already told you some advantages of the stationary armature. So we will see the advantages of stationary armature. What is the advantage of stationary armature? High voltage at high voltages. So we are going to tap out 440 volts out of this armature. It is easier to insulate the stationary armature windings, 30 kilowatt or more. Suppose if the rating of the alternator is some 2000 MVA or 5000 MVA, giving out 30 kilovolts. How do you insulate this armature winding if the armature is rotating? It is very difficult to insulate. So for that purpose, we have made the armature stationary. So this is the first point. The second point, the high voltage output we are going to tap out from the armature. So if the armature is rotating, it will be very difficult for us to tap out the high voltage. So that is why we are keeping the armature stationary and we are tapping out the voltage out from the armature. The rotor is a field winding. Low voltage DC winding, DC voltage can be transferred safely. So we are applying a DC excitation to the rotor, which is of low voltage. So that can be transferred safely, even if the rotor is rotating. But if your stator is rotating or your armature is rotating, you will not be able to tap out the high voltage, and you will not be able to insulate the armature windings properly. Due to simple construction, high speed of rotating DC field is possible. So this is one more advantage of stationary armature. So now we have understood the armature is stationary and the field is rotating, and we have seen the advantages also, insulation, and it is easy to tap out the power supply, 2 points. Now at what frequency this armature is going to generate the voltage? At what frequency? The frequency F equal to Pn by 120. So how it is Pn by 120? Just a simple derivation. The frequency of the induced EMF from the alternator can be given from this equation, F equal to Pn by 120. So read the statement. Every time a complete pair of poles crosses the conductor is rotating. The conductor is rotating. For one revolution, it will cross a pair pole. You should understand the difference between poles and pair poles. If there are 4 poles, how many pairs of poles are there? 4 போல் இருக்குது. அப்ப எத்தனை pair of poles இருக்கும்? Anyone? 2 போல் சேர்ந்து ஒரு pair. இப்ப 4 போல் மெஷின் அப்படின்னா எத்தனை pair இருக்கும்? Yes, very good. 2 pairs. So for one revolution, the conductor crosses all the 4 poles, or it crosses the pair poles. It crosses the pair poles. So F is given by frequency is number of cycles per second. Number of cycles per second. So number of cycles per revolution equal to number of pair poles, P by 2. P is the total number of poles. When you divide by 2, you will get the pair poles. So that is the number of cycles per revolution. So when you multiply P by 2 with the speed in RPM, RPS, N is in RPM. So if you want to convert to RPS, it is N by 60. So P by 2 is the number of pole pairs crossed by conductor in one revolution. In one revolution. So when it crosses one revolution, one cycle of EMF wave is produced. Positive half cycle and negative half cycle. So that positive half cycle and negative half cycle comprises of one cycle. So when your conductor crosses the complete pairs of poles in one revolution, one EMF wave is produced, positive half cycle and negative half cycle. And the number of cycles completed is P by 2. P is the number of poles. When you divide it by 2, it will get the pair poles, number of pair poles. When you multiply the number of revolutions per second, you will get the frequency of the induced EMF. Simple concept. Frequency is nothing but number of cycles per second. Number of cycles per second. So P by 2 into N by 60, which is Pn by 120. So from this equation only, we have derived the equation for speed. F equal to Pn by 120. So N equal to 120 into F by P. So this is a very important equation. You'll be using it in the problems. So please take a note of this formula. It is Pn by 120. F equal to Pn by 120. So the frequency of the output voltage, that we are going to tap out from the armature of an alternator will be F equal to Pn by 120. It depends on the number of poles. And also the speed. Number of poles and also the speed. In last class, we have discussed about the EMF equation of an alternator. So what is an EMF equation? What is the EMF equation? What is the EMF equation? See, this was our EMF equation, right? 4.44 Fi into T. So how did we derive this? The rate of change of flux is going to induce a EMF. So we calculated what is d phi. D phi by dt equal to V. We calculated what is d phi. We calculated what is dt. D phi equal to P into phi. P is the number of poles. Phi is the flux. Dt is the time taken for n revolution. So 60 by n. So when you use these two concepts here, average induced EMF is equal to d phi by dt, which is nothing but phi p by 60 by n. So phi np by 60. So this is the EMF equation of the alternator. So when you substituting n equal to 120 F by P in the previous equation was phi np by 60. Instead of this n, just now you have seen F equal to 120 F equal to Pn by 120. So n equal to 120 F by P. So you have to substitute instead of this n 120 F by P, you will be getting 2 Fi. So if the average, there are Z conductors connected in series per phase, so average induced EMF will be 2 Fi into Z. 2 Fi into Z. So Z equal to 2T. We have already seen for one conductor there are 2 turns. So for Z conductors there will be 2T turns. So 2 into F into phi multiplied by 2T, you will get 4F by T. And this is the average induced EMF. How will you calculate the RMS value of the induced EMF? You multiply it by the form factor. The average value multiplied by the form factor, you will get the RMS value. So we stopped with this 4.44 F into 5 into T. Hope you remember this equation. The EMF equation, the EMF generated out of the armature is 4.44 F(t) in magnitude, and the frequency of this induced EMF is F equal to Pn by 120. So you remember this. But we are going to make some small alterations here. We are going to make some small alteration in this. We are going to introduce two terms. One is Kd, the other one is Kc or Kp. We are going to make some small alterations, Kd or Kc. The Kd is the distribution factor and the Kc is the pitch factor. You will see what is Kd and what is Kc in detail now. Before going into this pitch factor and distribution factor, let me show you an animation of how this winding is formed. Just hold on, I will share my PPT now. Is the PPT visible?
Yes, sir.
Okay. So now let us take a three-phase machine. Let us assume it has two poles and there are 18 slots. Slots are the regions where you have your windings. You remember, slots are places where you put the windings, and there are two poles. It is a three-phase machine. Assume these are the two poles. Assume these are the two poles, and we have 18 slots. The slots are distributed between the poles. We have 18 slots, and this is where you have to put the windings in the slots. And what is this coil span? I am introducing a new term here. Coil span. Coil span is nothing but your number of slots per pole. Coil span is the number of slots per pole. So if there are two poles and 18 slots, how many slots will come under one pole is your coil span. Now can you tell me what is the coil span here? What is the coil span here? Number of slots is 18. Number of poles is 2. So what is the coil span? Yes, it is 9. Balaji D, your answer is correct. Durga Prasad, answer is correct. What about others? I am getting no responses. Perumal, 9. So there are 9 slots per pole. 9 slots per pole. That is why there are 9 lines I have drawn in one pole. Coil span equal to 9. So what do you mean by coil span? The length of the coil. The length of the coil. Now I'm going to show you how this windings are formed. So we will start from the first slot. We will start from the first slot. We will end up with the 10th slot. We will end up with the 10th slot. So your coil span will be 10 minus 1, which will be 9. Is it clear? This is how the windings will be formed in the slots. Coil span 9 na first slot la winding start agum, 10th slotல winding end ஆகும். புரியுதா இல்லையா? Is it clear? Okay. And this coil span will be equal to 180 degrees. We should remember, for a full pitched coil, there are two types of coils: full pitched coils and fractionally pitched coils. If the coil span is 180 degrees, the winding is called as the full pitched windings. If the coil span is less than 180 degrees, it is fractional pitched windings. So here I am telling two more new terms: fractional pitched windings and full pitched windings. Full pitched winding means coil span equal to 180 degrees. Fractional pitched winding means coil span equal to less than 180 degrees. What about the second winding? What about the second winding? Second winding should be connected to which part? Second slot should be connected to the winding in the second slot should be connected to 11. Yes, very good. What is 11 minus 2? 11 minus 2 is 9. So your coil span is 9. So second winding should be connected to 11th slot. The winding in the second slot should be connected to the 11th slot. And third should be connected to which slot? The winding in the third slot should be connected to, yes, 12 minus 3 is 9. Should be connected to 12th slot. So this forms one pair of coil or one coil. So number 1, 2 and 3 will form one group. Number 4, 5 and 6 will form one group. Number 7, 8 and 9 will form one group. So why there are 3 groups here? I am introducing one more term, M. What is M? M equal to slots per pole per phase. Now you know the number of slots is 18. And the number of poles P is 2. And the number of phases is 3. Can you tell me the value of M? My value of M is 3. Correct. So there will be 3 coils which will be grouped, or 3 conductors grouped to form one coil. 3 conductors grouped to form one coils, and one more 3 conductors grouped to form other coil: R phase, Y phase, and B phase. So M equal to these 4, 5 and 6 and 13, 14, 15 will form another group. 7, 8, 9 and 16, 17, 18 will form a other group. Is it clear? So in this diagram, I have told you how to calculate the coil span. Coil span for a full pitched winding is 180 degrees. Coil span can be calculated by slots per pole, and these conductors are grouped into 3 pairs, and that is called as M. M equal to slots per pole per phase. Is it clear? This is how the windings will be. Hope you are clear with this animation. Now with the understanding of this, we will go to the pitch factor and distribution factor. Just hold on, I will share the PDF again. Now I already told you the EMF equation for an alternator is 4.445Ft. That is for a concentrated winding. But in an alternator, the windings are distributed. Windings are distributed. So because of that, there will be some drop in the EMF. So the drop in the EMF has to be taken care. In order to take care of the drop in the EMF, we are introducing two terms, Kp and Kd. Kp is called as a pitch factor, Kp or Kc, whatever. If you call, you can call it as Kp or Kc. Kp is the pitch factor, and Kc is the Kp is the pitch factor, and Kd is the distribution factor. So first you look into the pitch factor. So there is a 4-pole, 3-phase machine having 24 conductors. So remember, 4 poles are there, and there are 24 conductors. So how will you calculate the number of slots? The conductors divided by the poles. If there are 24 conductors, you 24 by 4, you will have 6 slots. You have 6 slots. If you have 6 slots, what will be the coil span? For a full pitched winding, what will be the coil span? தம்பி சொல்றது புரியுதா? இதுக்கு முன்னாடி அந்த அனிமேஷன்ல 18 ஸ்லாட் இருந்தது. 18 ஸ்லாட்ல இருந்து காயில் ஸ்பேன் கண்டுபிடிச்சோம். காயில் ஸ்பேன் எப்படி கண்டுபிடிச்சோம்? How did you find out the coil span? What is the formula for coil span? Or let me go to the next diagram. You can understand it easily. Okay, there are 6 slots. There are 6 slots. So your coil span will be 7 minus 1 equal to 6. Your winding should start from the first slot and it should end at the 7th slot. Then only you will be having 6 slots in between. So 7 minus 1 is how much? 7 minus 1 is 6. So your coil span is 6. If your coil span is 6, it is called as a full pitched winding. But look at this dotted line. If you, instead of connecting the winding in the 7th slot, if you take it to the 6th slot, if you take it to the 6th slot, it is 6 minus 1, 5 is the coil span. Coil span has now reduced to 5. So the total number of slots is 6. Coil span is 5. Coil falls short by 1 slot. So or it falls short by 30 degrees. Such type of winding is called as fractional pitched windings. So this is a solid line starting from 1 and ending to 7. The coil span is 180 degrees. That is called as full pitched coils. This dotted line is called as fractional pitched coils. It is falling short by 30 degrees. So 180 minus 30 will be 150. Now your coil span is reduced to 150. Such type of coils is called as fractional pitched coils. Hope you are clear. Now we'll go to the previous slide. If coil span equal to pole pitch, it is called as full pitched windings. If coil span is less than pole pitch, it is called as short pitched windings. So make a note of it. Coil span equal to pole pitch, it is full pitched windings. Coil span less than pole pitch, it is short pitched windings. How will you calculate the pole pitch? Pole pitch is the number of conductors per poles. Pole pitch is the number of conductors per poles. There's one more formula you need to know. Pole pitch equal to number of conductors per pole. Or basically you're calculating the number of slots. The definition for full pitched coil is coil span equal to pole pitch. The definition for short pitched winding is coil span is less than pole pitch. So if the coil span is equal to 180 degrees, it is a full pitched coil. If the coil span is less than 180 degrees, it is a fractional pitched coils. Coil pitch, coil span, everything is same. Pole pitch, pole span, everything is same. Hope you are clear. If you are not clear with the definition, this diagram you can easily understand. Coil span is 180 degrees, it is full pitched. Coil span is less than 180 degrees, it is fractional pitched coils. Why this is done? Usually in alternators, the coil span will be less than 180 degrees, or we will be using fractional pitched coils only. Why it is done? To save the copper of end connections. That is the first point. Why we need to save the copper? So these are the end connections. These are the end connections, this triangle part. This is called as the overhang. The overhang does not contribute to any EMF. Overhang does not contribute to any EMF. So since it does not contribute to any EMF, we need to reduce the size of the overhang. So the solid line, look at the amount of copper required. Look at the amount of copper required. It is very high, or you need more amount of copper. But whereas look at this dotted line. Look at this dotted line. So this is the amount of copper that is required. So this is fractional pitched coils. Dotted line is fractional pitched coils, and the solid line is full pitched coils. So fractional pitched coils results in saving of copper. Our end connections are overhang. This overhang length is reduced. That is one advantage. Save copper of end connections. That is the first advantage. Hope you are clear. The second advantage is improve the waveform of the generated EMF. Improve the waveform of the generated EMF. Sine wave, we will be getting a similar to a sine wave. We will not get a pure sine wave. There will be some harmonics in it. So we are in order to get a pure sine wave, we are going to use a fractional pitched windings instead of using a full pitched windings. And it will also eliminate the high frequency harmonics. We will discuss in the forthcoming classes what is harmonics and how the harmonics are induced and how we can avoid this harmonics. So one way to avoid harmonics is to use fractional pitched windings. And what are the disadvantages? Voltage gets reduced. Since the conductor length is reduced, the voltage is also reduced, and it is also slightly out of phase. So due to that, the resultant vectorial sum is less than the arithmetic sum. We will come to this vectorial sum and arithmetic sum little later. As of now, understand, we are going to use a fractional pitched windings. We are not going to use a full pitched windings. I think it is 10:25. We want me to continue the class, or we will continue by 11 o'clock? Do you want a break or we'll continue? Anyone? தம்பி இருக்கீங்களா?
Sir, continue, sir.
Continue பண்ணலாமா? Okay, we'll finish off that. Everyone is okay with that? Another half an hour?
Continue பண்ணுங்க sir.
Okay. ஒரு half an hour முடிச்சிடலாம். So this is denoted by pitch factor. Pitch factor or distribution. Pitch factor is given by Kp or Kc. So இதுக்கு முன்னாடி வரைக்கும் என்ன பார்த்தோம்? We are using fractional pitched windings instead of full pitched windings. Because of this fractional pitched windings, there is an angle of short pitch that is introduced, 30 degrees. 30 degree, this angle is called as alpha. The alpha is called as the short pitched angle. Alpha is called as a short pitched angle, and that factor which reduces the coil span by 30 degrees is called as the pitch factor. Very simple, Kp. So Kp can be calculated by vector sum divided by the arithmetic sum. Kp is the pitch factor, and this factor is introduced because we are using a fractional pitched windings. Fractional pitched windings reduce the coil span by some angle, and in order to incorporate that reduction, we are going to introduce this pitch factor. And this pitch factor can be given by this equation, Kp equal to vector sum by arithmetic sum. So how will you calculate the arithmetic sum and vector sum? Suppose if you take the arithmetic sum, the EMF induced in the coil is Es. First coil is Es. If the EMF induced in the second coil is also Es, what is the arithmetic sum? You will simply add Es and Es, and you will get 2 Es. This is the arithmetic sum. But vector has both magnitude and direction. So you need to take into account the angle also. Vector sum by arithmetic sum. So arithmetic sum, simply you add it, vector sum, since vector has both magnitude and direction, the resultant has to be calculated in a different way. So arithmetic sum we have calculated, vector sum, this is the vector sum. So ES is the EMF induced in full pitched coils. So this ES is the EMF induced in fractional pitched coils. The angle is alpha. What was the angle in the previous example? What is alpha in the previous example? I've shown you one diagram, right? What is alpha? How many degrees? How many degrees? Yes, 30 degrees. Very good. So how will you calculate the resultant of this ES and ES displaced by an angle alpha? You have to find out this ER. How will you find out this ER? So you draw perpendicular from this point, the green color line. Draw perpendicular from this point. Take this triangle. If this angle is alpha, this angle is alpha by 2 by the property of triangles. This is alpha by 2. You take this triangle. This triangle. Find out what is this distance. Find out what is this distance. So this is adjacent side. This angle is alpha by 2. This green color line is the opposite side, and this side is the adjacent side. So this distance is ES. So ES projected horizontally. ES cos alpha by 2. Adjacent side by hypotenuse. Adjacent side by hypotenuse. Your adjacent side is this side. ES cos alpha by 2. Is it clear? Adjacent side by hypotenuse. So half of the distance is ES cos alpha by 2, but we need the resultant ER. So it is twice ES cos alpha by 2. This is the opposite side. This is the adjacent side. This is the hypotenuse. So use the triangle formula and find out what is this distance, ES cos alpha by 2. But we are interested in finding out the resultant ER. Interested in finding out the resultant ER, it is twice this distance. So 2 into ES into cos alpha by 2. So this is the vector sum. What was the arithmetic sum? Arithmetic sum was 2 ES. Our vector sum is 2 ES cos alpha by 2. So you divide both, 2 ES cos alpha by 2 divided by 2 ES, you will get cos alpha by 2. So this is nothing but your pitch factor, where alpha is called as the angle of short pitch or short pitched angle. It is also called as short pitched angles. So clear? Now we have derived an expression for Kp, and we are going to introduce this Kp in the EMF equation. Hope you are clear. Once again, I will try to explain. The windings are not full pitched in alternators. The windings are always short pitched because of some advantages. Because these windings are short pitched, the EMF produced is getting reduced. By what factor? The factor is Kp. And that factor we have derived it to be Kp equal to cos alpha by 2. As of now, you understand this. EMF alternatorல ப்ரொடியூஸ் ஆகிறத கம்மி ஆகுது. ஏன் கம்மி ஆகுதுன்னா, நம்ம வந்து ஃபுல் பிச்டு காயில்ஸ் யூஸ் பண்றது இல்ல. We are going to use short pitched coils only because of some advantages you have seen. Saving in copper, to reduce harmonics, various reasons. அந்த அட்வான்டேஜ் இருந்தாலும் EMF ரெடியூஸ் ஆயிருது. EMF எவ்வளவு ரெடியூஸ் ஆகுது? By this factor Kp, and the expression for Kp is cos alpha by 2. Alpha can be anything between 0 to 180 degrees. So this is pitch factor. The next one is distribution factor. Before going to the distribution factor, you look at this diagram. This is a problem to calculate the pitch factor. Look at the first diagram A. Look at the first diagram A. What is the coil span here in first diagram? What is the coil span in first diagram? Anyone? If it is full pitched coil is 180 degrees, The coil should start at first slot. It should end at 10th slot if it is 180 degree. So what is the coil span if it is full pitched coils? Yes, very good. It is 9. 10 minus 1 is 9. That is the coil span if it was full pitched coils. But we are going to use a fractional pitched coils. Instead of connecting in 10th, we are going to connect it to 8. Now what is the coil span? Now what is the coil span? Yes, 7. If it was a full pitched coil, it was 10 minus 1, 9. If it is a fractional pitched coil, it is 8 minus 1, 7. So full pitched coil span 9. Fractional pitched coil span 7. So what is the short carding angle? It is short carded by how many slots? Full pitched 9 slots இருந்தது. Fractional pitched 7 slots இருக்குது. எத்தனை slot கம்மியா இருக்கு? 2. Very good. The winding is short corded by 2 slots. So that is why this 2 here. So how will you calculate the angle alpha? Alpha equal to the coil is short corded by 2 slots and the coil span for full pitched coils is 9. You multiply by 180 degree. 2 by 9 into 180 degree. So your alpha will be 40 degrees. So what is one slot angle? The distance between this 1 and 2 is how much? Distance between this 1 and 2 is how much? எவ்வளோ டிகிரிப்பா? இப்போ காயில் வந்து 2 ஸ்லாட்டுக்கு ஷார்ட் கார்ட் ஆயிருக்கு. அப்போ ஆங்கிள் வந்து 40 டிகிரி. ஸோ அப்போ ஒரு ஸ்லாட்டுக்கு இன்னொரு ஸ்லாட்டுக்கு உள்ள ஆங்கிள் என்ன? 20 degrees. Yes, very good. So it's 20. Between 1 and 2 it is 20. 2 and 3 it is 20. 3 and 4 it is 20. 4 and 5 it is 20. 5 and 6 it is 20. 6 and 7 is 20. 7 and 8 is 20. 8 and 9. If you add all these 20, you will get 180 degrees. ஆனால் நம்ம வந்து என்ன பண்ணியிருக்கோம்? Full pitched coils யூஸ் பண்ணாம short pitched coils யூஸ் பண்ணியிருக்கோம். For some advantages, this length of the overhang is reduced, saving in copper to reduce the harmonics. அந்த ரீசனுக்காக ஷார்ட் pitch பண்றோம். எவ்வளோ ஆங்கிள் ஷார்ட் pitched angle? 40 degrees. Now what is the formula for Kc? Kc equal to cos into alpha by 2. Cos alpha is 40 degrees. Just now we calculated 2 by 9 into 180. So cos of 40 by 2, cos 20. Kp equal to 0.94. Is it clear? Coming to the second diagram, can you tell me the coil span? Second diagram, what is the coil span? Yeah, it is 12. How the coil span is 12? 13 minus 1. It is 12. For full pitched coil, the coil span is 12. Now, how many short cording? The winding is short corded by how many slots? 10 minus 1 is 9. Previously it was 12. Now it is 9. So it is short corded by 3 slots. So how will you calculate the angle alpha? 3 by 12 into 120 degrees. So it is 45 degrees. How will you calculate Kp? Cos into 45 degrees divided by 2. So cos of 22.5, it is 0.924. So your EMF induced is going to reduce by this factor 0.94. Your EMF induced is going to get reduced by this angle 0.924. Is it clear? புரிஞ்சுதாப்பா? இந்த ப்ராப்ளத்தை படிங்க. Calculate the pitch factor for given windings. How many slots are there? 36 slots are there. How many poles are there? 4 poles are there. Coil span 1 to 8. This is for B. A க்கு வந்து 36 stator slots, 4 poles. அப்போ ஒரு போல் கீழே எவ்வளவு ஸ்லாட்ஸ் இருக்கும் சொல்லுங்க பார்க்கலாம். இது வந்து ஒரு போல் கீழே எவ்வளவு ஸ்லாட்ஸ் இருக்கும்? How will you calculate the number of slots? 36 ஸ்லாட்ஸ் இருக்கு, 4 போல் இருக்கு. ஒரு போல் கீழே எவ்வளவு ஸ்லாட் இருக்கும்? 9 ஸ்லாட் இருக்கு. வெரி குட். 9 ஸ்லாட் இருக்கும். அதான் இங்க பாருங்க, இங்க என்ன போட்டிருக்காங்க பாருங்க, ஏல. So look at the subdivision A. 36 ஸ்லாட் இருக்கு, 4 போல் இருக்கு. This rectangular part is the pole. இதே மாதிரி 4 இருக்கும். அப்போ ஒரு போலுக்கு கீழே எவ்வளவு ஸ்லாட் இருக்குன்னா 36/4, 36/4. Yes, 9 exactly. Christy, you're correct. 9 slots are there. You know how to draw the diagram. First winding, first slot ஆரம்பிச்சுன்னா அடுத்த winding எங்க போகணும்? 10th ஸ்லாட்டுக்கு போகணும். அதான் full pitched. ஆனா நம்ம என்ன பண்றோம்? ஷார்ட் கட் பண்றோம். Coming to subdivision B, 72 ஸ்லாட் இருக்கு, 6 போல் இருக்கு. ஸோ ஒரு போலு கீழே எவ்வளவு ஸ்லாட் இருக்கும்? 72/6. 12 slots இருக்கு. வெரி குட். 12 slots. So this is the winding pitch factor. Next we'll go to the distribution factor. But distribution factor க்கு once again I will go to this animation. Just hold on. Look at this animation. There are 2 poles and there are 18 slots, and the windings are distributed in these 18 slots. Windings are distributed in these 18 slots. இப்போ இந்த 18 ஸ்லாட்ஸ்ல இந்த வைண்டிங் டிஸ்ட்ரிபியூட் பண்றதுனால இந்த EMF இன்டியூஸ் ஆகும்ல இந்த ஒவ்வொரு வைண்டிங்ஸ்லயும், that EMF induced will be displaced with each other by the slot angle. We have already seen the slot angle is 20 degrees in the previous example. So EMF induced in the coil present in first slot will be different from the EMF induced in coil present in second slot by this angle, slot angle 20 degrees. For example, in the previous problem, the EMF induced in the third winding present in the third slot will be different from the second slot, which is because it is displaced by 20 degrees from the first slot. So this type of winding is called as a distributed windings. Windings are distribute பண்ணுவோம் ஸ்லாட்ஸ்ல. கான்சென்ட்ரேட்டட் வைண்டிங் என்ன? எல்லா வைண்டிங்கையும் பஞ்ச் பண்ணி ஒரே ஒரு ஸ்லாட் ஃபர்ஸ்ட் ஸ்லாட்ல மட்டும் போட்டுருங்க. 18 ஸ்லாட் இருக்காது, ஒரே ஸ்லாட்ல போடும் எல்லா வைண்டிங்கும். ஒரே ஸ்லாட்ல போட்டா அதுக்கு பேர் வந்து concentrated winding. If you distribute the windings in these slots, it is called as distributed windings. So this animation shows you how the windings are distributed. So in the concept ஞாபகம் வச்சுங்க. With this in mind, we will discuss the distribution factor. சரி, இப்போ நான் சொன்னது அப்படியே நான் வச்சு இந்த சென்டென்ஸ் படிச்சு பாருங்க. As you know, each phase consists of conductors distributed number of slots to form a polar group under each pole. So நம்ம போலார் குரூப்ல எவ்வளவு கண்டக்டர்ஸ் இருந்தது? 3 கண்டக்டர்ஸ் இருந்தது. இப்போ 3 போலார் குரூப் இருந்தது. Do you remember that m equal to slots per pole per phase were 3. So number of polar groups were 3. ஒரு போலுக்கு கீழே 3 கண்டக்டர்ஸ் இருக்கும். Because of this, the EMF induced in the conductors constituting the polar groups are not in phase. First conductor, second conductor, third conductor, மூணுக்கும் EMF induce ஆகிறது, it is not in phase because the slots are displaced angularly by some angle, and that angle is called as slot angle. Hope you are clear with this. Next diagram பார்த்தா உங்களுக்கு clear ஆகும். So what is KD? KD is the EMF induced if the winding is distributed to the EMF induced if the winding is concentrated. Concentrated na எல்லா வைண்டிங்கும் பஞ்ச் பண்ணி ஃபர்ஸ்ட் ஸ்லாட்ல மட்டும் போடணும். அப்படி போட்டா EMF induced in all the coils will be same. Since we are using the EMF, since we are distributing the windings over the slots, the EMF will be different because of the displacement of the slots. The concept. So இங்க பாருங்க, for a 3-phase machine with 36 conductors and 4 poles, 36 கண்டக்டர் இருக்கு, 4 போல் இருக்கு. அப்ப எவ்வளவு ஸ்லாட்ஸ் இருக்கும்? How many slots will be there? 36 conductors, 4 poles. How many slots will be there? Yes, very good. 9 slots will be there. இது வந்து ஒரு 3 phase machine. இது வந்து ஒரு 3 phase machine. ஸோ அப்போ ஒரு ஃபேஸுக்கு எவ்வளவு ஸ்லாட் இருக்கும்? மொத்தமா 9 ஸ்லாட்ஸ், 3 ஃபேஸஸ். ஸோ ஒரு ஃபேஸுக்கு 3 ஸ்லாட்ஸ். So that is this, each phase consists of 3 slots. So angular displacement between any two adjacent slots is 180 degree divided by n. N is the slots per pole. N is the slots per pole. So 180 divided by n. So n is 9, number of slots. N is the number of slots. 180 is the degree and n is the number of slots. 180 degree by 9 is 20 degrees. That is the slot angle. Angle between one's first slot and the second slot is 20 degrees. So இதுக்கும் அதே மாதிரி தான் நம்ம கண்டுபிடிக்க போறோம். Vector sum by arithmetic sum. Vector sum by arithmetic sum. So this is the பீட்டாங்கிறது தான் ஸ்லாட் ஆங்கிள். பீட்டாங்கிறது தான் ஸ்லாட் ஆங்கிள். It is 180 degree divided by n. It is nothing, n is nothing but the slots per pole. Previous example எவ்வளவு ஸ்லாட்ஸ் இருந்தது? 9 ஸ்லாட் இருந்தது. So slots per pole was how much? Here the number of slots is also called as number of conductors. Don't get confused. The conductors 36 conductor இருக்கா, divided by 4 pole போடுறோமா, 36 by 4 எவ்வளவு? 9. இதை மட்டும் ஞாபகம் வச்சுங்க. Conductors by pole. N is conductors by pole ஞாபகம் வச்சுங்க. 36 by 4 is this n. So 36 by 4 was this n. So that is why this 180 by 9. 180 by 9 is 20 degrees. So clear? When you look at an example, it will be easier for you. As of now, you understand. Here in the bracket, it is written as conductors. You take this as conductors only. Number of conductors per pole. So beta is the slot angle. How you will calculate the slot angle? Beta equal to 180 degree divided by n. 180 degree divided by n. N is the number of slots per pole. Number of slots per pole எப்படி கண்டுபிடிப்பீங்க? Number of conductors divided by number of poles. In the previous example, number of conductors were 36 and number of poles were 4. So that is why 36 by 4 was 9. So 180 by 9 was equal to 20 degrees. So இதில் arithmetic sum கண்டுபிடிக்கணும். அதுக்கப்புறம் vector sum கண்டுபிடிக்கணும். Arithmetic sum எப்படி கண்டுபிடிப்பீங்க? ES plus ES plus ES. That is 3 ES. ES is the EMF induced in the first slot. ES, this ES displaced by an angle beta is the EMF induced in the second slot, winding in the second slot, and this ES displaced by an angle beta with respect to this slot is the EMF induced in the third slot. So இதோட vector sum எப்படி கண்டுபிடிப்பீங்க? Since vector has both magnitude and direction, you have to take both these angles also. இப்போ இந்த ER is 3ES. Arithmetic sum is 3ES. What is the vector sum? That is what you are going to calculate in the next step. நல்லா கவனிச்சிங்க. This ES is the EMF induced in the ES இருக்கு இல்லையா, இந்த ES is the EMF induced in the first slot. And what is the slot angle? இதுதான் second slot, இது third slot. Slot angle என்னது? Beta. Angle between the first slot and the second slot is beta. Again, this angle between the first slot and second slot is second slot and third slot is beta. Third slot and fourth slot is beta. Fourth slot and fifth slot is beta. So if this angle is beta, what will be the half of this angle? It is beta by 2 in the distance. In the distance will be beta by 2. Now you take this triangle, the whole triangle, or perpendicular varanju, you bisect it. You take this triangle alone. You take this triangle alone. This angle is beta by 2. You hold on 1 minute. ஒரே நிமிஷம் இருங்கப்பா. So ES is the EMF induced in one slot, and the slot angle is beta. You draw a perpendicular from this point to this resultant ES. Now we are going to take this triangle. We are going to take this triangle. If this whole angle is beta, half of the angle is beta by 2. Half of the angle is beta by 2. So in this triangle, what is this distance? This is opposite side by hypotenuse. Opposite side is sine. So R sine beta by 2 is this distance, half distance. Now in the total ES வேணும். But total ES எப்படி கண்டுபிடிப்பீங்க? Twice of this half distance. So 2R into sine beta by 2. 2R into sine beta by 2 is this total distance. ES. நமக்கு என்ன வேணும்? இந்த ரிசல்டன்ட் வேணும். ER வேணும். இந்த ரிசல்டன்ட் ER வேணும். The resultant ER எப்படி கண்டுபிடிப்பீங்க? வெக்டார் சம் ஆட் பண்ணணும். இதோட ES plus ES plus ES plus ES. This is the vector sum. So this angle is beta, means this whole angle we'll call it as M beta. The whole angle we'll call it as M beta. If this is ES, we will multiply with M into 2R sine beta by 2 to get the resultant. So this is what is displayed now. R into sine m beta by 2 is half this distance. So total distance will be twice R into sine m beta by 2. This is the vector sum. This is the vector sum. So we have calculated the vector sum and the arithmetic sum. Arithmetic sum was 2R sine m beta by 2 and the vector sum was m into 2R sine beta by 2. So this m will remain. This 2R and 2R will get cancelled. So KD equal to sine m beta by 2 divided by m sine beta by 2. So this is the equation for KD. KP can equation cos alpha by 2. KD can equation sine m beta by 2 divided by m sine beta by 2. So this is KD. This KD also reduces the EMF induced in the alternator because we are using distributed windings. EMF gets reduced. Because we used fractional pitched windings, EMF gets reduced. So fractional pitched windings, there is a winding factor Kp, pitch factor Kp. Distributed windings, there is a factor Kd. In the Kp Kd ரெண்டு ஃபேக்டரும் EMF induce ஆகுறத கம்மி பண்ணது alternatorல. That is the final conclusion you should understand. So now we will do a small problem. Calculate the distribution factor for a 36 slot 4 pole single layer 3 phase winding. This is the problem. 36 slot இருக்கு, 4 pole இருக்கு, single layer 3 phase winding. Don't worry about the single layer and double layer. I will explain in some other class what is single layer and double layer. As of now, you understand 36 slots are there, 4 poles are there. How will you calculate N? Beta equal to 180 degree divided by number of slots per pole. That is the formula. How will you calculate N? Slots per pole. Number of slots is 36 and number of poles is 4. So 36 by 4 equal to 9. What is the formula for beta? Beta equal to 180 degree by N. 180 degree by 9 is 20 degrees. So what is the angle between one slot and other slot? It is 20 degrees. The slot angle is 20 degrees. And what is this M? The polar group. This M is the polar group. Slots per pole per phase. M is the slots per pole per phase. So 36 by 4. 36 is the slots. 4 is the poles. Number of phases is 3. So M will be 3. So you found out all the terms. M beta நமக்கு வேணும் KD கண்டுபிடிக்கிறதுக்கு. KD ஓட ஃபார்முலா வந்து sin m beta by 2 divided by m sin beta by 2. So you will get an answer of 0.96. You will get an answer of 0.96. So hope this is clear. So 0.96 by this factor, the EMF is getting reduced. So finally, we are going to incorporate these two terms in the EMF equation. So this is the final EMF equation of the alternator. 4.44 phi ft kp into kd or kc into kd. So this is the final EMF induced equation. Hope this is clear. புரிஞ்சுதாப்பா? சரி, why we are discussing about this kp and kd? எதுக்கு இந்த kp kd டிஸ்கஸ் பண்ணோம் இவ்வளவு நேரம்? You will conclude the class in another 5 minutes. Meanwhile, you answer these questions. You will conclude the class. kp எதுக்கு introduce பண்ணோம் EMF equationல? Anyone? kp எதுக்கு introduce பண்ணோம்? kd எதுக்கு introduce பண்ணோம்? இதை மட்டும் சொல்லுங்க பார்க்கலாம். We will conclude the class. Satya Devi. Satya Devi, are you there? Satya Devi ஆளை காணோம். அரவிந்த் ஆர்கே. Aravind is also not there. Balaji. Balaji is also not there. Bhuvaneshwaran. பாலாஜி இருக்கியா? chat பண்ற. Pitch factor எதுக்குப்பா கொண்டு வந்தோம்? Anyone? Why we introduced this pitch factor in this EMF equation? ரெண்டு கொஸ்டின் தான். இந்த கொஸ்டினுக்கு ஆன்சர் பண்ணிட்டீங்கன்னா we will conclude the class. Pitch factor எதுக்கு introduce பண்ணோம்? Distribution factor எதுக்கு introduce பண்ணோம் இந்த EMF equation? Simple question. Yes, very good. Pitch factor for fractional pitched windings. நம்ம full pitched winding யூஸ் பண்றது இல்ல, அதனால fractional pitch winding யூஸ் பண்றதுனால pitch factor introduce பண்ணோம். சரி, distribution factor எதுக்கு? வைண்டிங்ஸ் எப்படி இருக்குது? டிஸ்ட்ரிபியூட்டடா இருக்குதா, கான்சென்ட்ரேட்டடா இருக்கா? டிஸ்ட்ரிபியூட்டடா இருக்கு. டிஸ்ட்ரிபியூட்டடா இருக்கிறதுனால we are using this factor kd. இப்போ இந்த ரெண்டு ஃபேக்டரும் EMF ரெடியூஸ் பண்ணுமா ஜாஸ்தி பண்ணுமா? செகண்ட் क्वेश्चन. Yes, very good. It reduces the EMF equation. எதுக்கு fractional pitch windings க்கு போறோம்? What are the advantages of fractional pitched windings? Although it reduces the EMF equation, why you are going for fractional pitched windings? Very good. Uses less copper to avoid harmonics. அவ்வளவுதான், simple. எதுக்கு distributed winding போறோம்? I think that point is not discussed. We will discuss in the next class why we are going for distribution factor. See, if the winding is concentrated, the other slots will be left free. If the other slots are left free, there will be some leakage flux or there will be some air gap introduced. So because of which the EMF is reduced. That is one point. We will discuss this distribution factor. Why we are going for distribution factor next class. Because of this Kp and Kd, EMF gets reduced. And we have done two problems. One in pitch factor and one in distribution factor. Both are very important 2-mark problems. So you make a note of it. So if எல்லாரும் notes எடுத்துட்டீங்களா? ஏதாவது diagram இது வரையாம இருக்கீங்களா? Have you drawn all the diagrams? Have you noted down all the problems? The class முடிஞ்ச உடனே இதை சப்மிட் பண்ணோம் கூகுள் கிளாஸ் ரூம்ல. டெட்லைன் இஸ் டுடே. ஏதாவது டயக்ராம் வரையலன்னா சொல்லுங்க. I will display the diagram for 5 minutes. You can draw the diagrams. Have you drawn all the diagrams? I will display this diagram for 2 minutes. Those who have not copied it, you please draw this. இந்த டயக்ராமும் வரைஞ்சுக்கோங்க பார்க்கலாம். ஒரு 2 நிமிஷம் I will be in the meeting. Then we will wind up. Once you have drawn this diagram, you let me know. Then I will go to the next diagram. And Christy has asked doubt in the chat. In the circuit diagram, use which circuit diagram? The circuit diagram is present in the virtual lab itself. All the connections are present in the virtual lab itself for load test of alternator. You do that load test. I already shared you the link. Don't worry about the circuit diagram. Everything is present in the virtual lab itself. So on the circuit diagram, you conduct a load test and tell me what is the EMF generated under various conditions. Under various excitations, the EMF will be increased. So tell me what is the relationship between excitation and the EMF induced. So உங்களுக்கு ரெண்டு அசைன்மெண்ட் இருக்கு. ஒன்று கிளாஸ் நோட்ஸை சப்மிட் பண்ணணும். இன்னொன்று அந்த எக்ஸ்பெரிமெண்ட் பெர்ஃபார்ம் பண்ணி அதோட டேப்லர் காலமும் கிராஃபும் சப்மிட் பண்ணணும் இன்னைக்குள்ள. ஸோ ஹோப் யூ காப்பிட் திஸ் டயக்ராம். அடுத்த டயக்ராம் போறேன். விஜய் இருக்கியாப்பா? ரெப்ரஸன்டேட்டிவ் 21 பேர் தான் வந்திருக்காங்க. 20 பேர் ஆப்சென்ட். ஒரு மெசேஜ் போட்டு ஏன் வரலன்னு கேட்டு சொல்றியா?
ஓகே சார்.
நான் நம்ம வாட்ஸ்அப் குரூப்க்கு ரிப்ளை பண்ணிடுறேன். வாட் இஸ் தி ரீசன் கேட்டு ரிப்ளை பண்ணு.
ஓகே சார்.
Thank you. So this lecture is recorded. I will share you this video also in Google Classroom. You can refer to this video. In case of any doubts, you can refer to this video I will share this video hopefully by tomorrow or day after tomorrow. So with this, let us wind up today's class. And you have 2 assignments: one to update your class notes and to update your experiments. So next week we look into the armature reaction. We look into the armature reaction in alternator, and we will derive the phasor diagram of a loaded alternator. So all this we will see in the next class. So if there are no doubts, we can close the meeting. இல்ல காப்பி பண்ணிட்டீங்களா? எல்லாரும் காப்பி பண்ணிட்டீங்களா? ஏதாவது டயகிராம் காப்பி பண்ணுமா?
சார் விர்ச்சுவல் லேப்ல சர்க்யூட்டே இல்லை சார்.
விர்ச்சுவல் லேப்ல சர்க்யூட் இல்லையா?
எஸ் சார், அந்த எக்ஸ்பெரிமெண்ட் சர்க்யூட் இல்லை சார்.
சரி, நான் சர்க்யூட் அனுப்பிச்சு விடுறேன். வாட்ஸ்அப் குரூப் அனுப்பிச்சு விடுறேன்.
ஓகே சார்.
சர்க்யூட் இல்லைனாலும் அந்த ப்ரொசீஜர் இருக்கும் இல்லைங்க, இந்த ப்ரொசீஜரை பார்த்து அப்படியே கனெக்ட் பண்ண வேண்டியதுதானே.
ஓகே சார்.
ப்ரொசீஜர் கொடுத்துருப்பாங்கப்பா, ப்ரொசீஜரை பார்த்து அப்படியே கனெக்ட் பண்ணீங்கன்னா அதான் சர்க்யூட் டயக்ராம். எனிவே ஐ வில் சென்ட் யூ தி சர்க்யூட் டயக்ராம், டோன்ட் வரி. கனெக்ஷன்ஸ் ஆல்சோ நாட் கிவன். ஓகே, நான் ஒரு give me half an hour time. I will look into that and tell you how to proceed. கிளாஸ் முடிஞ்சோடனே நான் அதை பார்த்துட்டு உங்களுக்கு வாட்ஸ்அப் குரூப்ல அப்டேட் பண்றேன். அதான் இது வந்து காலேஜ் ஆஃப் இன்ஜினியரிங் பூனே இல்லையா, அதனால டிஃப்ரெண்ட் பிளாட்ஃபார்ம். ப்ரீவியஸ்லி யூ ஹவ் டன் இன் ஐஐடி ரூர்க்கி, அதனால அதுல எல்லாமே இருந்தது. ஓகே, லெட் மீ சி. அப்போ இந்த எக்ஸ்பெரிமெண்ட் அப்படியே பெண்டிங் வைங்க, இந்த கிளாஸ் நோட்ஸ் மட்டும் அப்டேட் பண்ணுங்க. நான் சொல்றேன் எப்படி எக்ஸ்பிளைன் பண்றதுன்னு நான் சொல்றேன். Okay, fine. If there is nothing, I will close the meeting. Vijay, copy பண்ணிட்டியாப்பா?
பண்ணிட்டேன் சார்.
Okay. So we will see next week with the armature reaction and phase diagram of alternators. Thank you, students.